Hi, I'm Lauren Bennett, and I'm going to make an etching on copper using Velvetint, which replaces Aquatint. Velvetint eliminates the need for hazardous materials such as powdered rosin, asphaltam, ammonia, whiting, and petroleum-based solvents. I will etch the copper plate using a bath of kosher salt and water, which is safer than ferric chloride. The saltwater etch is activated with only 3 volts of DC current. This etch also works on zinc and aluminum plates. Everything you need to know about Velvetint and etching with saltwater can be found in this new textbook, Printmaking Revolution, written by Pogue. I begin by filing a slight 45-degree bevel on the edges of the copper plate. Then I use a Norton 150 grit sanding pad from a hardware store to smooth the filed edge of the plate. To polish the plate, I use a Norton ultrafine 320 grit polishing pad. I lightly go in opposite 90-degree directions several times until the plate is fully polished. Next, I used a soft paper towel to carefully wipe the front of the plate and then the back to remove any filing particles or copper dust. I use a microwave oven to heat 4 cups of water for 9 minutes. I cover the plate in the hot water for 10 minutes or until the water sheets off the plate perfectly when you tilt it. Using clean gloves, I quickly dry the back of the plate with paper towels. I carefully dry the front of the plate with a hairdryer. In a yellow lighted darkroom, I raise the plate on a level block of wood. I measure the size of the plate with a ruler using the scale provided in the textbook Printmaking Revolution. For a 6 by 9 inch plate, I need 1.5 eyedroppers of Posi-Coat. The darkroom should be vented, but there should be no fan blowing on the plate, as it will dry the coating before it has time to self-level. The brush must be clean, and I prefer a nylon fine bristle brush for coating. I brush the coating repeatedly in a 90-degree pattern. After fully covered, I carefully and lightly brush in both directions several times in order to make a nice consistent film. At this time, you may also coat several small strips of copper to use for test exposures. Once coated, I turn off the vent and let the plate cure in total darkness for 8 or more hours. I place the plate in the exposure unit and carefully align black 4-ply mat board around it as a support for the 21 micron stochastic dot screen. This prevents the screen from bending around the edges of the plate. I place the screen on the plate and expose it. Printmaking Revolution details how to determine exposure times and recommends exposing your test strips first. I developed the plate within the darkroom using aqueous-based developer. It is easiest to develop small plates when submerged in a tray. After 1 minute, I lightly brush over the plate with a developing sponge or a piece of cotton. I pour out the exhausted developer. I pour some fresh developer on the plate and agitate it vigorously this time. I always keep the plate covered with developer. I rinse the plate with water and dry it with a hairdryer, being careful not to touch the coating. The plate is ready to etch. Following the book's instructions, I make a sketch from my key image. I tape my key image drawing over the plate, and I slip a sheet of white transfer paper between my drawing and the coated copper plate. Using a red ballpoint pen, I trace the outline of my drawing onto the plate. The salt etch will not affect the transfer. Using various sized points of Sharpie paint pen markers, I draw over the parts of the drawing that I do not want to print. Stopping them out now ensures they will remain totally white. Just prior to etching, I clean the copper straps for the saltwater bath. I use a Norton 60 grit sanding pad. The secret to a good effective salt etch is to have clean metal and good contact. I also carefully clean the parts of the hangers that clamp over the copper strap. These sections are hard to see and should always be cleaned to ensure good contact. I I also clean the big copper screen on both sides with the sanding pad to remove any oxidation. I attach the copper hangers to the strap. I now tape my plate to the hangers, low enough to be submerged in the salt water of the tank. I use a clear, strong packing tape which will hold up through numerous etchings. I cover any exposed copper that is not part of the image. The hangers already have a heavy-duty white tape on the back side to completely protect them. I now adhere the plate to the hangers, and I rub it to make sure that it makes tight contact. I trim off all excess tape with a razor blade. I turn the plate over and cover the front side of the exposed copper straps with tape. I trim the excess tape off these straps as well. I insert the copper mesh screen into the grooves of the tank. I never allow the screen to stay in the tank overnight or when not in use, as the salt will form a film on the screen which will deter its effectiveness. I insert the strap with the hangers and the plate attached. I clip the black negative clamp to the screen and the red positive clamp to the plate strap and turn on the timer. My first etch time is for 1 minute. After etching the plate for 1 minute, I remove the red clamp and then the plate. I rinse it with water to remove the saltwater etch. I dry it with a hairdryer and begin stopping out more of my image to continue stage biting. To use biolac as a stop out, I pour 2 ounces in a jar and add a drop of food coloring for visibility. I mark a line on the jar at the level of the biolac. I leave the jar uncovered in a vented hood, and when the biolac has reduced by about 1/3 of the line on the jar, it is evaporated enough to make a thick stop out. I etch the plate again for approximately 1 minute and 40 seconds. When the timer goes off, I remove the plate and rinse the plate with water in the sink. I continue the process of stopping out the drawing using biolac and Sharpie paint pens. My next etching times will provide a range of light to medium tones. This third etch is for 3 minutes long. I continue to add more stop out to cover the light areas on my plate, which I just etched. I etch the plate again for another 3 minutes and 30 seconds. I use a wide-tip Sharpie paint pen to stop out larger areas on the plate and add more biolac with a paintbrush. I etch the plate for 4 minutes. I remove the plate and stop out one last time. This last etch will provide the darkest black tones in my image. I etch the plate for a final 5 minutes. The cumulative etch time was 15 minutes to achieve black. Your etch times may vary slightly, so it is always best to make a small test plate first. After the final etching, I remove the plate and peel the tape from the hangers to separate them. In a vented hood, I clean the plate with biosolute to remove the Velvetint coating and the stop-out materials. Allow the biosolute to sit on the plate for a few moments before rubbing it again with a rag. The plate is now clean and ready to print. I place the plate on a warm hot plate and apply the ink. I buff the plate with tarlatan and then wipe it with newsprint. I clean up the edges with a rag and place it on the press. I apply a dampened sheet of Reeves BFK and pull my first proof. Now that I have pulled a proof, I decide to add some finishing details using a roulette wheel and an etching needle for dry point. I burnish the plate to add highlights and to soften tones. If I decide to add an etched line, I can simply coat the plate with biolac to use as a hard ground. Thanks for watching. For more information on all the things you can do with Velvetint, such as 4-color separations, be sure to get a copy of Printmaking Revolution, published by Watson Guptill. The unusually low price makes the book very affordable for college students.